All right, so today we're going to talk about counting principles, which is just a different way to think about probability to calculate the number of outcomes that an experiment could have. So just as a reminder, make sure that your notes are all ready to go. Either you've printed them out or you've set up your notebook. This presentation problem you're going to turn into today's assignment. And so number 10 from 9.5, take a picture of that and attach it to this assignment. As long as you get it in by Friday, it's going to be on time. And then the rest are additional practice here so that you can master this topic and show me that you understand what's going on the quiz and on the check-ins. So let's get started. Student ID numbers are made of 5 digits. How many possible student ID numbers are there? So this is the idea with counting principles, is we're trying to count how many of something there could possibly be. Now, what I like to do with these type of problems is think about the different places that all these things could have. So what I will often do is I'll say, oh, I'm reading this and there's 5 digits. I'm going to go 1, 2, 3, 4, 5, and I'm going to think about each of the 5 digits separately. So that first place is the first digit, second digit, and so on. Then once I know how many different types of things I'm thinking about in here, types of numbers, looking at any type of problem, I'm then going to think about the number of possible outcomes for each of those things. So each of these is a digit, and that means that there are 10 possible outcomes. Those outcomes being 0, 1, 2, 3, 4, 5, all the way up to 9. So there's 10 possible outcomes, 10 possible digits for the first number, 10 for the second, 0 through 9 again, for the third, for the fourth, for the fifth. If this was something like a letter instead of a digit, there would be 26 possible outcomes because there's 26 letters, A through Z. So you have to sort of use a little bit of logic here. So now that we're thinking about each space as its own separate amount of outcomes, in order to figure out the total number, what we do is we just multiply all those spots together. So times 10, times 10, times 10, all the way out. And here's where you're just going to do a little arithmetic. 10 times 10 times 10 times 10 times 10 is 100,000. So there's 100,000 possible student digits for this problem. So if we're looking at something that's not digits, here we've got a sandwich shop where there's 2 choices of bread, 4 choices of fillings, and 5 choices of toppings. How many different sandwiches can be made if you pick 1 filling and 1 topping? So it's the same idea. In this case, you've got 3 possible types of terms: bread, fillings, and toppings. And so for each of these at this store, we have a different number of outcomes possible, unlike the digits where they were all the same type. Here, for bread, we have 2 possible outcomes. For fillings, we have 4. And for toppings, we have 5. But using the same logic, we can again follow the same step as number 1, multiply them all together to get our total number of different sandwiches that we could buy at this shop. 2 times 4 times 5, which is 40 possible sandwiches. So let me know if you have any questions about this in the Zoom call or in the comments below, and I'll talk to you later. Bye.